Welcome to the office. We want to continue taking a look at section 21 and let's see here, look at the theorems that will formalize the things that you found in your computer explorations. So some of these terms in the computer explorations may not have been obvious. Some of them yes, some of them no. For example, the three medians of a triangle are concurrent, right? I said that in the previous video, so maybe you knew that that would be the word that we're looking to use here. But then centroid, well, actually that one should have been relatively obvious as well, right? The computer exploration is on the centroid, so concurrent centroid there for 21.1. Here, I think that you should be able to find the appropriate distances. We will find that relationship in our theorem statement, so I'm not worried about that. Computer exploration 21.3 here. Again, we're looking to see that the three perpendicular bisectors are concurrent, right? That's expected. Circumcenter, that's what the that point of intersection is called. That should not be surprising. The thing that might have been a little bit more difficult to identify are the names here, right? You should also be able to identify what other points are on the circle. So I'll leave that blank for now because that should be obvious. But the circle is called the circumscribing circle. So the circle that goes around an object is the circumscribing circle, all right, containing all of the points of that object or that shape rather. And then to shorten the name, they just call it the circumcircle. For the incenter, again, the three bisectors are concurrent. That point, this right, should have been known, but it's called the incenter. As you draw a line, then draw a circle, or create a line. Yeah, so create a line. Anyway, yeah, you also are going to create a circle. How is it related to the triangle? Tangent on all three sides. That thing, this observation, I think you may have noticed, but maybe possibly didn't say or didn't quite say in the right way. So I wanted to make sure that was there. And then the circle is called the inscribed circle, right? Rather than circumscribed, inscribed. But then we, again, shorten it to the incircle, circle inside of the triangle, tangent to all sides. All right. Last computer exploration here that I asked you to complete. The three altitudes are concurrent, no surprise on the name. Orthocenter is what it's called, no surprise on the name. Okay, excellent. Looks like you also need this one a little bit later. I think I mentioned to you guys that you need to keep what was it? Yeah, the first one. Make sure you keep that open, or hopefully you did, because that was in, or will be yet in a later activity or computer exploration. All right, so with all of those done, we can look at some theorems. So let's take a look at two of them really quickly here. The median concurrence theorem is just a statement of what you found in your first and second computer exploration there. So the three medians of a triangle are concurrent. Yay, that's what you found. And then we said that the name of that point is the centroid. Fantastic. And then in that second computer exploration, you should have found that the distance from each vertex to the centroid is twice the distance from the centroid to the opposite midpoint. So a nice diagram right here. We're saying that the distance from the point to the centroid is twice that from the centroid to the side. Right? So this distance is twice this distance. So if this is 1, this is 2, for example. All right. A proof of this theorem, you would want to consider section 26 there, which we do cover. We'll take a look at that. All right. Next theorem, the perpendicular bisector theorem. So just a restatement of what you had found, formalized as a theorem. The three perpendicular bisectors of the sides of a triangle are concurrent at a point labeled R, called the circumcenter, which is also the center of the circle that contains all the vertices of the triangle. This circle that contains all the vertices is known as the circumscribing circle of the triangle, or simply the circumcircle. Excellent. And this is the proof of this is actually in the exercises. You're going to make use of the perpendicular bisector theorem, 12.11, and then also use this diagram, and that would be helpful. Excellent. So perpendicular bisector theorem is the existence of the perpendicular bisectors, and then use this theorem. Perpendicular bisector for each side, that's where they intersect, the concurrence of them. All right, excellent. So we want to take a look at two more theorems, which you have already found the conclusions for. 21.8 angle bisector concurrence and 21.9 the altitude concurrence. But here we do want to discuss the proofs. So we'll pause here for now and take a look at those remaining two theorems and their proofs in a couple of videos coming up here. So I'll see you guys back in the office in just a little bit.